This episode has kindly been sponsored by PCBWay, world leaders in the manufacture of high-quality custom printed circuit boards. And of course, they still offer great quality PCBs, with 10 boards starting out at just $5. But what's more, up until the 31st of December 2022, PCBWay, in association with Mouser Electronics, are running their 5th PCB design contest. This time around, they're focusing on next-gen hardware and eco-friendly projects, but you can still enter even if your project doesn't fit into either of these categories. The top prize is $1,500 cash, $200 worth of coupons, and a Raspberry Pi 4, plus many other great prizes for runner-up places. And even if you don't win, you'll get a Raspberry Pi Pico just for entering. So get yourself over to PCBWay.com and let them help you bring your projects to life. Hey, you doing, everybody? Greetings and welcome to another episode of 8bits in the Basement. So here in the basement, I'm very, very excited today. And the reason for it is a courier arrived at the house yesterday with a big parcel for me. And when I opened it up, inside I found this Apple IIe, which is fantastic. This is the very first, honest to goodness, computer from the 1980s that has been donated to this channel. And the person who donated it to me is Rudy from Rudy's Retro Intel. Now, you may remember that an episode or two back, I did a video on a little device that he had designed called the TinyComp. And its purpose is to provide composite video from a unit which only has an RF output. So he sent this to the channel as a donation. I thank him very much for it. Now, he told me that he's tested it and it's working away perfectly. But as this unit has come from the Canadian-American region, it means that it functions on 110 volt power. Here in Europe, we use 220 volts. So if I plug this into the wall as is and I power it on, what I'm going to get is smoke and a big bang. So what I need to do, first of all, the very first thing to do is to open up the power supply and see if we can convert that power supply from 110 volt power supply to a 220 volt one. And while we're at it, we'll change out the RIFA capacitor in it as well. Now, a RIFA capacitor are notorious for exploding, and very dramatically. They explode with a big bang, leave a terrible smell, cover a lot of the area where they've exploded in a kind of an icky smelling gunk. And basically, they're cheap, they're easy to replace, so there's no reason not to. So we'll do that while we're at it too. The unit's going to need a little bit of a clean as well. So we'll look at that as well. But once we have the power supply sorted up, what we want to do is we want to check and see if the video out is okay as well, because this is an American system. So it's given NTSC video out. Here in Europe, we use PAL, but I don't think it should be a problem because, well, these TVs, they're pretty much fairly modern, and I think they can handle both PAL and NTSC, but that remains to be seen. So not only did Rudy send me this computer, but inside of it there are a couple of cards which make it more fun to use, or I suppose more productive, really, in a way. What it's got inside of it is a card that will give us an 80-column display. And I'm not sure if that card also contains a memory upgrade or not. We'll have to look and see about that. There's also a peripheral card in there that will allow me to connect this to a printer. And there is a disk controller card as well, so that when I get some kind of disk drive device, I will be able to connect the disk drive to it. And also he has included a CPM card, which will allow me to run the CPM operating system on this system, and also the host of CPM programs that go along with that. So it really is quite a complete system. So it's going to need a little bit of a clean as well. So we'll have a look at disassembling the keyboard at some stage and cleaning that up too. But for the moment, what we're going to do right now is we're going to whip it open, see what it looks like on the inside. We'll take that power supply apart and see what secrets lurk inside and how easy it is to convert it from a 110 to a 220 volt power supply. So let's get to it right now, eh? Okay, so here I am with the Apple II. Now, this is the first time that I've ever really physically been in the presence of any Apple computer apart from a Macintosh that I used back in school back in 1993. But this guy here is a humongous gargantuan beast. I have to say, it's a huge system. It's much bigger than I expected it to be, yet it is surprisingly light. So There you go. I didn't expect it to be so light, but it looks to be built like a tank. It looks to be a very, very strong system. It's got a QWERTY keyboard on it, a full mechanical keyboard, and it's got Apple keys as well. It's got an empty Apple and a full Apple, and well, keys I've never really seen before, to be honest with you. Around the back, we find a system that really is made to be upgraded. Here what we have are a couple of ports. We've got our composite out for our TV. We've got audio in and audio out for a cassette, so we can load and save programs from and to cassette. And this guy here looks like a serial port to me, so I'm not sure exactly what it is. But you notice that there are 12 holes that are blocked in, if you like, and these are all for connectors. So the thing can be expanded, expanded, and expanded again. And it's also got its power supply over here with a nice little on-off switch. So this guy here is 115 volts AC. And that's the back of the unit. Up here you'll notice that there are 2 tabs here. And the reason for those is this is ingenious. So if you want to open this system, there are no screws or any of that to be fiddled around with. There's nothing you have to do to get inside the system to expand it. You just grab those 2 tabs that I showed and you firmly pull up and the top lid removes. And what we have is our motherboard and our PSU clearly labeled and available to us on the inside of the unit. So with the cover removed, here are the innards of the Apple IIe. You can see the motherboard here, which is a really neatly, lovely laid out board. Over here we've got the power supply. This is the guy we're going to be removing in a couple of minutes to see if we can modify it the way it needs to be modified. Our keyboard here is connected with this ribbon cable into a connector just here. And the motherboard itself, all I can tell you is pretty much what you can see because I know nothing of these. We've got 7 expansion slots, and actually we've got 8. And then we've got absolutely every dip chip on this board. All of them, memory, processor, absolutely everything, logic chips are all socketed. So it can be easily upgraded or easily repaired, I would imagine. There's one of the neatest, best laid out little boards I've ever seen. There's just one connector for power going here. And then, like I say, there is the keyboard cable going in there. And that's pretty much it. So from what I can see, the motherboard is held in with 2 screws here at the back, possibly a third one over here. But the power supply is screwed in from the bottom. So in order to remove that, which we need to do right now, we'll remove this connector here first. I can figure out how it's plugged in. There's surely a clip. Okay, so I can't remove that. It seems that I need to remove the power supply before I can get in at that to remove it. So that's what we'll do. I will flip the unit over and we will, if you take a look here, you can see that the power supply is sitting directly over these 4 screws. So I think it's fair enough to assume these 4 screws are holding that power supply in place. So we're going to remove those now and see if that power supply will come out for us fairly easily. And 4. Oh. And our power supply is released. A little bit, anyway. There we go. So, with those 4 screws removed, I can now get in here and I can action this and remove it. Excellent. So now I should be able to equally slide out the power supply, and I can. So there we go, one power supply with a big stain on it, all ready to be opened up, and we'll see if we can sort it out the way we need to sort it out. Now, so what I'll do is I will put the Apple to one side and we'll concentrate on the power supply. Okay, so let's have a look and see what this old power supply is saying to us. So it says, caution, under no circumstances is this case to be opened. This power supply is not user serviceable and there are dangerous high voltages inside the power supply case. In the event of difficulty, notify Apple Computer Incorporated or your dealer for prompt service. And it says here to always turn off the power supply before removing or installing peripheral interface cards. Failure to do so will result in damage to the Apple IIe and the interface card and will void your warranty. So what we have here is we have a serial number and the date of 1984. And there are no other markers. Oh, here we go. If I can get this to focus. Now this is something you have to love Apple for this kind of stuff. Well, back in the day at least, everything was documented on the machine. We've got the pinout right here for this machine, how it plugs in. And not how it plugs in, but what the actual outputs from the pins are. So this is, yeah, that's excellent. So what we're going to do with our made in Taiwan power supply is we're going to open it up. There are, as far as I can see, 10 screws holding it together. So we will undo all those and then we will see what we're faced with on the inside of the unit. So here you see me madly unscrewing the 10 screws. It's a lot of screws to have to unscrew. I removed the screws with a regular Phillips screwdriver. There's no kind of security bits or any of that kind of stuff needed here, although they were a little tight, which I suppose is kind of normal after 40 years of being screwed in. So once I had all those screws out, it opens up just like this. And now that we have it open, let me explain to you what we're going to do to it on the inside. There are two things we want to do inside here today. Number one, we've got this RIFA cap down here. You'll see it. It's this yellow guy here. And it's marked 0.1 microfarad with a little X on it. That guy there needs to be replaced. And I've got replacement caps for that, so we can do that straight away. To modify this power supply that only accepts 110 volt or 115 volt at the moment, so that it'll work here in Europe with 220 volts, there is this black cable here. See it right here behind this ferrite bead, and it goes to 2 points on the board, so it's bridging a point here with a point back here, and all we need to do is to remove that black cable completely, and this power supply should then be compatible with 220 volt. So that's what we're going to do. We are going to remove this from its case, and we'll get our desoldering pump going to remove this guy and remove this wire, and then we'll put a new one of those in, put everything back together, and we should be good to power up. Now, so the PCB of the motherboard is held in place with 6 Phillips head screws, and these need to be undone as well so that we can remove it to actually do the mods. But there's one or two other little things that are kind of preventing us as well from taking that out, and one of them is the bunch of wires over on the right hand side of the PSU there. So we need to try and remove that little grommet that's kind of holding all those in place. And what I discovered is you can actually turn that grommet thing inside in the metal there. And once you've turned it in such a way that it'll actually open, if you look at it, you'll see there's a little kind of hinge on it. You can action that little hinge with a flathead screwdriver and it'll pop open, and then you can easily remove it. Now, over on the other side of the power supply, where the switch is and where you plug in the power cable, you'll notice that it's kind of held in place. There's a brown wire going into a live part of the board. It's marked as live. And there's also a negative wire, or a blue wire, that's going into the board as well. I found that I could remove the brown wire. That came out easily enough. But the negative one, the blue one, wouldn't come out. So I kind of had to leave it in place and just turn the board around as best I could, but I found that I could get the board around in such a way that I could work on it. So using my solder sucker, I managed to remove the solder on the RIFA cap, and it came out quite easily. And here's the cap that I intend to replace it with. Now, this is the old RIFA cap. You'll notice that it's a 250 volt, and it's rated at 0.1 microfarad, and it is an X, which means it's for AC side. So here is the replacement capacitor that I have for it. Now this is supposed to be an even better one. This is a RIFA again. It is 100 nanofarad, which is 0.1 microfarads, exactly the same thing. And it's an X2.
although this guy here is rated for 275 volts. So it should be a better all-round capacitor. Now these guys don't have polarity, so we'll just shove it in any old way and we'll resolder it in place.
Now, here's a little pro tip for you in case you don't know. Whenever you're inserting a RIFA cap, always make sure that you have your camera completely out of focus. And then once it's inserted, realize it's out of focus and focus it when it actually doesn't make any difference anymore. Okay, so I bent the legs of the RIFA cap over. And then I realized that I hadn't actually plugged in my soldering iron. So instead of plugging in the soldering iron and waiting to solder it in, I decided to solder on and remove the wire from the 115 volt select lines that we saw earlier. So I removed one side quite easily and then the other. Okay, we have removed that wire. So with the iron heated up, I soldered in the RIFA cap and then I cut its legs down. So what have we accomplished?
A new RIFA cap installed here, and we're after removing the wire that went to the 115 volt select.
So I was just about to button everything back up when I saw that there was a fuse inside the PSU. So I decided, as it's open, I might as well check and see that that's working properly.
There we go. Okay, so we have continuity across the fuse.
And then I put everything back together again. I put everything back in the reverse order of how I took it apart. So let's go see if it works. Okay, so we have a modded power supply here now. So what I want to do is I want to check, number one, that I can plug it into the wall here and turn it on without it going bang, that it now accepts 220 volt. And the other thing I want to do is I want to check the voltages coming from it before we plug it into the Apple, because I don't want to blow up the motherboard on the Apple. So I want to be very careful here. I'm going to plug the power in here first without it being plugged into the mains. That's the number one thing. And we will plug this guy into the main socket now. First thing I'm going to do, and I don't know if this is a good idea or not, I'm going to touch it like that. Okay, so it doesn't seem to be live or anything. We'll turn it on. All right, we haven't gotten a bang. Doesn't seem to be live there. We will set the multimeter to, this is set to DC voltage. Now, I don't know if you can see that there or not, but you can. So I was looking at this here earlier. So it gives us our pin out, and there is no discernible pin 1 on this thing. So what I discovered was that this is marked with 2 ground lines, and it has 5 volt, 12 volt, minus 12 and minus 5. But this guy here, if you want to find the grounds, it's obviously the 2 black wires here. So what I'll do is I will tuck into one of the black connections here, and this guy here should be giving me, of course I'm covering everything, but this is giving me 5.5 volts. Here I am getting 13.01. Here I'm getting minus 12. And here I'm getting minus 5. So those voltages look to be right to me. And it means that removing this little cable here has done the trick. It has converted this over to a 220 volt power supply. And judging by this guy here and the way the voltages are on the connector here, she's good to plug into the Apple, and she is also good to to power it. So let's do that now, eh? So far so pleased on this. I've got the power supply modified to work with 220 volts, and we verified it. It's given the correct voltages. It's back in the Apple II. It's been plugged back into the motherboard, and I'm after joining the Apple II to the TV here using an RCA cable. So from the component video out of the Apple II, or the composite video out of the Apple II, into the AV port on the back of the TV here. TV is powered on, everything is plugged in, so when I flick this switch, this should at least beep. We'll see if we get a picture, but it should at least beep. Oh, Woohoo! Look at this. We've got an Apple II. Look at this, Apple II. Hang on. 10. Print. Oh, there's a little green LED here. Print. How do I go to 10 and run? Syntax error. Now, I don't know why. I'm doing something wrong. There's something about BASIC I don't know right here. But that's fine. We're not going to worry about that. We'll get rid of line 20, for example, and we will just run it with line 10. Whoops. Syntax error, apparently. Or maybe I have to use, do I have to, hang on. 10, print. If I do it that way, without any spaces, because I kind of fecked around with the Yoki. LLO, world, ORLD, and shift, and this guy. And then we run. Syntax error. Okay, I don't know how to use an Apple. Oh, maybe I need to, maybe it's waiting for some kind of disk command input, whereas I need to get into some kind of, I don't know, maybe I need to, I don't know how to work it. No. So, anyway, the Apple II appears to be working, but I don't know how to work it yet. So I'm going to go do a little bit of research on how to get a Hello World program running on this, and we will try and get a Hello World program running on this. Okay, so let's do that. So I figured out what I was doing wrong, and actually it's quite simple. But how could I have known? It appears that the Apple II here, you need to be typing in programs and commands and whatnot with the caps lock key pressed down. So everything needs to be written in uppercase. If not, it's seen as syntax errors. So what I've done is, with the caps lock key pressed down, I've tapped in the 10 print hello world and 20 go to 10 again. And now if I type run with caps lock still pressed down to give me block capitals and press return, the hello world program works. So the computer is working. Now I'll be honest, I thought we were in some kind of disk operating system thing, and I needed to load up a version of BASIC in order to do it. But no, BASIC is contained on a 16 kilobyte ROM inside in this system. So that's a good thing. Now to get out of this, I press Control and C, and that'll break me out. And then I can type list, and I get my listing. If I type list with caps lock turned off, I get a syntax error. You see, so that's what I was doing wrong. Now, there's one other thing. If you want to check the system to see if it's working properly, to check the memory in it and whatever chips and whatnot are in it, you can actually do it. There are built-in diagnostics on this system. What we do is we press Control, we press the closed Apple key, and we press Reset. And what we get are these white kind of blocks on the screen that flash and stuff. And this isn't all that verbose. It won't actually tell you that anything is wrong unless something's wrong, which makes sense. But if everything passes, what it will do is it'll print kernel OK up here in the top left-hand side of the screen. For other versions of the Apple other than the 2E, it'll tell you system OK in the middle of the screen, and it's also much more colorful as it goes through the tests. But it shows that the system is working properly. So that really is as much as I can do with this for today. Now, there is a tape port on the back of this, so we can load up software using WAV files and whatnot. So I've been looking into that. And in an upcoming episode, what we're going to do is we're going to give this computer a good cleaning, because it needs a good cleaning. And what we're going to do also is we're going to have a look at loading software using that tape port, because I don't have an actual disk. A disk drive as such for it. And the other thing we're going to do is I got 4 cards. We're going to have a look at that 80 column card, and we'll have a look at some of the other cards as well and see how they work, or how well they work with the unit. So there's still more to come down the road on this system. So what I'm going to do is I'm going to wrap up this episode, and I'm going to leave you with a Star Wars joke. So how did Wicket the Ewok get around Endor? Ewoked. At least said the better, huh? So what we're going to do in the next episode is what I said. I'd just like to thank Rudy from Rudy's Retro Intel for donating this system. This is fantastic, it really is. And there's plenty more coming on this actual system down the road. So until the next episode, everybody, take good care of yourselves, and we'll talk to you all very, very soon. PD out. Bye-bye.